Hello, this is Jack Boyd, FAA Designated Pilot Examiner. And I'm going to present another episode of Rambling with a DPE. These are case studies involving safety and accident investigation in many cases. So let's talk today about NEXRAD versus radar. What happens when you think you have radar and you actually have NEXRAD? An NTSB accident report says the CFI certificated pilot and his student were flying a Cirrus SR-22 and were issued a suggested vector to avoid extreme precipitation while flying in an area with active air mets for IFR and icing and an active convective SIGMET for thunderstorms. The PIC responded to ATC that he could see, quote, the areas of precipitation on my weather radar, unquote. The controller replied, deviate left or right as necessary. The pilot's mistake in believing NEXRAD was the same as radar and telling that to ATC placed the burden of avoiding thunderstorms squarely into PIC's lap from the controller's response. We must all know NEXRAD is not radar. NEXRAD depicts precipitation that probably was there 20 minutes or more ago, not what is actually there on your MFD or your weather screen. The Cirrus then encountered extreme precipitation and turbulence and downdrafts, losing nearly 17,000 feet of altitude in under a minute. The propeller RPM increased from its normal 2,700 to over 3,300 RPM, which is basically a prop overspeed. Probably because the PIC failed to reduce power during turbulence encounter and uncontrolled descent. The engine failed shortly after due to internal damage from the overspeed. The Cirrus's airframe parachute, known as CAPS, was deployed, and the crew exited the Cirrus unharmed. NTSB probable cause was the PIC's improper use of NEXRAD. What's the takeaway from all this? NEXRAD should be used for limited situational awareness. We should request vectors from ATC when avoiding convective weather, and not to rely on NEXRAD alone. Avoid severe and extreme precipitation by at least 20 nautical miles. Reduce power when entering areas of moderate and severe precipitation. Slow to VA, or maneuvering speed. How do we know if there are areas of moderate and severe precipitation using NEXRAD? Well, again, NEXRAD is 20 minutes old. So watching trends of color change is probably a good way of maintaining situational awareness with the weather. Colors changing from green to yellow typically mean that the intensity of precipitation is increasing. Precipitation changing from yellow to green obviously indicate that the weather is declining in intensity, reducing in intensity. So you want to watch that. You also want to see the movement over time. If the weather is moving from east to west, then you can assume that what you're looking at is 20 minutes further to that direction and has either increased in intensity or decreased in intensity to what you see now. Slowing to maneuvering speed is always advisable when entering moderate to severe precipitation, as I said. That way you'll most likely mitigate loss of control structural damage or possible engine damage, as this PIC did. I hope you learned something from this, and hope you take away a safer attitude about convective weather and NEXRAD and radar. Fly safe, friends. Jack Boyd, over and out.